Hello there again. Here comes Unit 4, where we're going to talk about procedures in feed formulation. The recommended reading for this section is going to be in Chapter 4 of your text. We'll try and keep this to a brief recording. In this particular lecture, we'll have to spend more time in the classroom going over some of these procedures and examples. A few things on the objectives here. I'll let you read those very quickly. But really what we hope to get out of this section is to give you a basic understanding of feed formulation and ration balancing just in a simple mathematical method using the Pearson square. So first things first, what will we need to get started? And of course you need some to determine the nutrient requirement data. That information comes from extension and university research sources and the NRC, which is the Nutrient Research Council. They meet periodically and determine the nutrient requirements of all the different species and publish a data set on a periodic basis that really guides all of ration balancing. Then, of course, we need some feed analysis data, whether that's forage test data that, like we've discussed in previous units, send a hay analysis off to the laboratory and get the feed report back and utilize that in your data sampling, or simple feed library nutrient profiles, which is what we will utilize in the classroom. The procedural outline, and I've kind of tried to give you a step-by-step practical approach here. Determine the ration needs, identify the nutrient requirements that those animals have, figure out what feedstuffs are available. You've got to use what you have access to. Of course, we'd like to perhaps from time to time feed a number of other different things, but on occasion those feeds that might sound good in a ration just simply aren't available. For those available feeds, then we've got to figure out what the nutrient composition is, again through that feed test data or the textbook values. Balance the ration, and whether we're looking at crude protein, dry matter intake, TDN, or all of the above, we want to go ahead and get that ration balanced. Check the mineral vitamin concentrations. I generally suggest doing that last because movements in crude protein of those feeds usually also change the mineral vitamins as well. And so that's kind of a last or an ending step to balancing your ration. Always then recheck for errors. Find and correct deficiencies or excesses that you might have, and then take a moment and pause and think about palatability. Will they actually eat what you're proposing the ration is balanced? Will they actually consume it? And then calculate cost. Again, we've kind of tried to underscore this cost component throughout the course, and I think we would be remiss if we didn't continue to belabor that point. We have to have a good idea in terms of what rations will cost our producers on a daily basis. Some techniques then in ration formulation, and we are going to focus on the Pearson square method. Let me come back to that here in a second. Let me just pause and talk briefly about the algebraic approach. The algebraic approach gives you the opportunity to balance for multiple nutrients at one time. So for example, you could balance for crude protein and total digestible nutrients and crude fiber and crude fat all at the same time. It gets to be, of course, then as you think about that, a pretty long and arduous task. It's quite a bit more difficult, and it's as you're dealing with all those things, quite a bit easier to make mistakes. So I don't particularly teach the algebraic method. If you're really interested in that, it's covered nicely in your textbook. I think for today's approaches, it makes most sense to either do a simple Pearson square approach, like I'll show you, or find a computer-based resource that can really help you get pretty exact. So the Pearson square method only does one nutrient at a time. So it will only do crude protein, or it will only do total digestible nutrients. And consequently, those will be the two ones that we tend to focus on in the class. So one nutrient, two ingredient options, and the number at the center of the equation is always the balance point. And as a rule, and I'll share this again, that number in the center of the equation must be in between the numbers on the left side of the equation. And we'll show you an example here in a subsequent slide. So let's formulate an example ration. We're going to put together a example 16% crude protein diet for a pig. The ingredients that we're going to use are corn, which is typically 9% crude protein, and a supplement that we purchased from the store that carries 36% crude protein. So we want to determine what percentage of the diet will be corn and supplement. So let's get to our example here. This slide is going to be busy. I'm going to try and slowly click through all of the items that are going to come in. So our balance point is 16. Okay. The two ingredients that we discussed, 9% crude protein corn, 36% crude protein supplement. These should go at the corners of your Pearson square box. What we're going to do is we're going to subtract diagonally across the equation, just like so. Ignore the percentages and ignore the negatives. That's really, really critical in doing this correctly. I know it's going to be a little bit mathematically confusing until you get the hang of it, but we're going to subtract across the equation diagonally. So 9 minus 16 is 7, and we're going to ignore the negative. Okay. So as we get to the right side of the box then, and we've subtracted diagonally, the 9 minus 16 is 7 parts, and that's actually 7 parts supplement. 36 minus 16 is 20, and that would be 20 parts corn. We're going to add those two things together to have 27 total parts. Basically, we're creating ratios here. Just as a reminder, these feeds stay here. We subtract diagonally, but that ingredient does not go with it. The corn, if you have corn on the top, corn stays on the top. If you have supplement on the bottom, it stays on the bottom. So don't drag the ingredient with the number. That's a very common mistake that many make the first few times that they're doing the Pearson square. So as we add 20 parts corn and 7 parts supplement, we get a total of 27 total parts. Very simply then, we're just going to divide the parts by the whole. And so if we take 20 divided by 27, 20 parts corn divided by 27 total parts, 74% of the diet is going to be corn. Same thing with the supplement, 7 parts supplement divided by 27 of the whole is 26% supplement. Notice these things add up to 100 and should add up to 99 or 100 based upon how you rounded throughout doing the equation. So here our ration is in balance. If I'll show you in class how to check and make sure that we're correct. But this would constitute a balanced ration at 16% crude protein. So hopefully then our pigs will be happy. If we go to the next slide, I just want to reiterate that if our pigs then are eating 5 pounds a day, if we take 5 pounds per day consumption times 74% of the diet is corn, we would have to feed them 3.7 pounds of corn. If they're eating 5 pounds a day and 26% of it is supposed to be supplement, they'll eat we'll need to feed them 1.3 pounds of supplement. Again, if we add this 3.7 and 1.3, that should give us 5 total pounds. So again, our ration is in balance and should deliver 16% crude protein. So, of course, as I explain it, it's probably sounds very easy. And I may have lost you at some point in time. Trust me, we'll do plenty of practice in the classroom. But you can pause and run this back a number of times and kind of follow the steps and utilize this whenever you get stuck as you're working on your homework and so forth. So things as we're talking about using the Pearson square. The balance point, that number that's in the middle, it must be between the two ingredient numbers. So as I back up here, these two numbers on the left side, the 9% and the 36, this number in the center must be somewhere in between these two numbers. So let's say, for example, I propose that you would use 9% crude protein corn and 12% crude protein oats to create a 16% diet. The first thing that you should do is say that's not possible. I can't make a 16% diet with two ingredients that have less crude protein than my balance point. So that's impossible. It won't work that way. So you have to select a different ingredient. So if you come across that as a possible opportunity when you're balancing your ration, just know right up front that's the answer. Can't do it with those two ingredients, have to find something else. Okay, so that number in the center must be in between all the time. When you're doing 3+ ingredients, because that is a limitation, that Pearson squares can only do 2 ingredients at a time. What you do is create a series of mixes and different crude protein percentages, so we kind of back into the targeted ration crude protein content. We'll practice a little bit of that just to show you how it works. Again, always check your math and recheck for accuracy. It's super, super important that you verify that your math works correctly. I would highly suggest in the classroom and your assignments, show your work all the time. That way I can follow what you're doing mathematically, and you'll tend to capture a few more points. We'll do a lot more examples in the classroom. I'm going to stop there in terms of a recorded lecture series on these kind of things, because again, I think it will get A, monotonous, and B, more confusing. So we'll talk about some more examples in the classroom and give you some things to work through that we can do together. So of course, then the other option that we will work on down the road is computer-assisted formulation. There's a lot of different programs out there. There's many, many options. Some of them are publicly available for sale, and some are proprietary that companies own and do not share with the public. But just know that there are several options out there, and of course, as with anything else, some better than others. You have the ability when you go into those programs to adjust nutrient profiles. So if you have alfalfa hay on the farm, you get it tested, you can go in and adjust that nutrient profile, or you can just use the standard feed library. My suggestion is, if you have feed test data, if you have feed test data, always use it. That's super critical. Use what is most pertinent to you. And then these programs calculate the ration nutrient requirements and then compare it to what is being delivered. So as you begin to punch the numbers in of the amount of corn and soybean meal and dicalcium phosphate and alfalfa hay and dried distillers grains and soybean hulls that you want to feed, it will then calculate what is being delivered versus what is required, and it will give you readouts on how accurate you're being and it will then suggest what changes you need to make. They work quite well, and we will practice a few of those tools as we get further on in the course. So some simple take-home messages is these. You can do basic ration balancing at this point. Once we master the Pearson square, you have some basic knowledge of ration formulation and nutrient needs. Those finishing steers or horses that you might have at home in the backyard, you can balance your own ration. It doesn't take a lot more expertise than what we just practiced. So you can kind of get an idea whether you're feeding appropriately. Remember, the Pearson square only does 2 ingredients at a time. That's a limitation of it, but there's ways that we can get around it. And then again, with computer-assisted formulation, it's much, much simpler, and we will practice something similar to what the professionals use in the industry in subsequent units. Hopefully this helps you with the unit 4 content. I'll look forward to practicing some examples and having our discussion in the classroom. Thanks for listening in again.